Okay, today we'll revise chapter 5, lesson 1, thermal energy, temperature, and heat. We'll say only the main points we talked about here. Okay, we talked about kinetic and potential energy. We talked about kinetic and potential energy. This is the first point here. So we said any moving object has what? Kinetic energy. So what is the meaning of kinetic energy? Kinetic energy is the energy the energy of an object or particle that because of this what? Moving. So the energy of motion is what its name is kinetic energy. Okay? And as the speed of the object increases, the kinetic energy increases. Also, we said we have another kind of energy. It's called what? Potential energy. Potential energy. Okay, and potential energy is what, as you see here, is stored energy. Stored energy. So potential energy is stored energy due to the interaction between two objects. Like when we have Earth and the ball. Okay, like Earth and the ball, this is the Earth and there's a ball. There is a distance, or there is a ball at a height from Earth. So because of this height, the ball has potential energy. And as we increase the height, the potential energy increases. If we increase the height, so the potential energy increases. Okay, and we said the sum of potential energy plus the kinetic energy, okay, of an object. Pay attention, I'm talking about the object like the ball. Okay, so the sum of kinetic energy and potential energy give us what? Mechanical energy of the object. Okay, so we are talking about what? The mechanical energy of the object. Again, what is the meaning of kinetic energy? It's energy of motion, the energy an object or a particle has because it is moving. And it depends on speed. As we increase speed, the kinetic energy increases. The second energy is potential energy. We say potential energy is stored energy, okay? And if we have two bodies due to interaction between the two objects. So potential energy is stored energy due to the interaction between two objects, like we said, the ball and the earth, and it depends on height. If we have two balls, this ball has this height and this one has this height. So this ball has more potential energy because it has more height. Okay. If we added the potential energy, okay, plus the kinetic energy, okay, of an object, so we are talking about mechanical energy. We are talking about mechanical energy. The second point is thermal energy. Thermal energy. What we said about thermal energy? We said thermal energy is like mechanical energy, but what is the difference? That thermal energy, okay, is the sum of the kinetic energy and the potential energy of what? Of the particles. Of what? Of the particles. Okay? This is the ball, it is the object. So it has mechanical energy. But when we talk about the particles inside the ball, like the air particles, so we are talking about what? Thermal energy. Thermal energy. Okay, so again, what is the meaning of thermal energy? Is the sum of the kinetic energy and the potential energy of the particles that make up a material. Okay, so thermal energy describes what the energy of the particles. Pay attention. If I give you a question, okay, the kinetic and potential energy of particles. It is mechanical or thermal. When I say particles, so you have to notice what? Thermal energy. Thermal energy. And here, mechanical energy of soccer ball. Mechanical energy of soccer ball equal kinetic energy plus potential energy. We are talking about the object, soccer ball. Okay? But if we talking about the particles thermal energy, kinetic equals kinetic energy of all particles plus the potential energy and also between the particles. So pay attention for this different thermal energy, mechanical energy. Here we have potential, we have kinetic, here we have potential, we have kinetic, but here we are talking about the object, here we are talking about the particles. Then we talked about what is temperature. What is temperature? We said for temperature represents what? Temperature represents the average kinetic energy of the particles that make up a material. So any particle, we said, has kinetic and potential energy. But temperature only needs the kinetic energy. Temperature only what? About the kinetic energy. So here, temperature represents the average kinetic energy of the particles that make up a material. Okay? So temperature, shabab, pay attention, it is the average kinetic energy. Okay? So, and as it is the average kinetic energy, so if we increase the kinetic energy, so we have a high temperature. The greater the average kinetic energy of the particles, the greater the temperature. Why we have why a material has high temperature than another material? If we have material A and another substance or material B, okay, and there is particles inside. Why material A reads 30 degree Celsius? Why material B 20 degree Celsius? Okay, because the particles in material A has more kinetic energy or has greater kinetic energy. Okay, so kinetic energy relates to temperature, or temperature relates to kinetic energy. Okay. So again, so here, how are temperature and kinetic energy related? We have to say that temperature represents the average kinetic energy of the particles that make up a material. Now to the most important point, measuring temperature. Measuring temperature. Many of you text me on WhatsApp so about this point, measuring temperature. We said, how can we measure? How can you measure a temperature? We said you can use thermometer to measure what? Temperature. You can use thermometers to measure temperature. We said we have two kinds of thermometer. The number one is a bulb thermometer. A bulb thermometer. Okay, this bulb thermometer. Okay, what is inside the bulb? It is a bulb is a glass tube. We have a glass tube connected to a bulb that contains a liquid such as alcohol or mercury. Okay, and we said when the temperature of the alcohol increases, the alcohol what expands. So when the temperature increases, the alcohol expands and rises in the glass tube. When the temperature decreases, okay, so the alcohol what contracts back into the bulb. Okay, and we said the height of the alcohol in the tube indicates what? The temperature. Okay, we can see the figure of the thermometer down here. So remaining friends are entering the room. Here, so there is a bulb what? Thermometer. Okay, this is the glass. This is the glass tube. This is the glass tube. This one is a glass tube. This connected to this bulb. This is a bulb. This is made of metal. We put the alcohol or mercury inside. Okay, when we put it in a hot water, so the alcohol or the the mercury rises up because the temperature increases, expand. When the temperature increases, the alcohol expand and rises up. When the temperature decreases, the alcohol contract and come back to the metal pump. This is how the bulb thermometer works. Okay. The other kind of thermometer we named is what? Digital or electronic thermometer. Okay. The other one is electronic thermometer. The other one is electronic thermometer. Okay. What is the idea of this thermometer? We said it measures, it changes in the resistance of an electric circuit. Okay. So what is the idea of electronic thermometers? We said before what? Measures the resistance or a change in resistance. The bulb thermometer measures a change in height or a change in length of the alcohol, but here it changes in resistance of an electric circuit. And then it will convert this change, okay, to temperature. Okay. I hope this point is clear. So they ask you, what is the working idea? The working idea of electronic, the working idea of electronic thermometer. We say it measures, it changes in the resistance of an electric circuit. The working idea of bulb thermometer, when the temperature increases, the alcohol expands. When the temperature decreases, the alcohol contracts. We said before. Okay. So now we know the tool, the thermometer, but we need a measuring unit for the thermometer to tell us the amount of temperature. Okay. So we have here three scales. We have three scales. The first scale, and pay attention for this paragraph, everyone. It has a lot of information. All the lines are important. Okay. So the first one is Fahrenheit and Celsius. Okay. The first one, Fahrenheit scale. You have to know that freezing point and boiling point. But the freezing point is the starting point. Then the boiling point, it is the end point. So for Fahrenheit, water freezes at 32 degrees and boils at 212 degrees. Right, what about Celsius scale? Okay, water freezes at 0 degree and boils at 100 degrees. Okay, right. Now we have Fahrenheit and Celsius. Pay attention. So this is the first difference: freezing point and the boiling point. Right. Which one is used by scientists worldwide? Yes, the Celsius. The Celsius scale is used by scientists worldwide. Okay, if I ask you which temperature scale is used by scientists worldwide, Fahrenheit or Celsius or Kelvin, okay, so your answer must be what? Celsius. Okay, so Celsius scale is used by scientists worldwide. Okay, the other one, this is the first one we said Fahrenheit, the second one we said Celsius, the third one is Kelvin scale. Kelvin scale. What is the freezing point of water and the boiling point? Okay, we said the freezing point of water is the starting point. It freezes at 273 K. You have to remember those numbers, and boils at 373 Kelvin. Okay, so there's a comparison between Fahrenheit scale, Celsius, and Kelvin. You have to know the freezing point and the boiling point for each one. Here is 32, 0, 273, 212, 100, okay, 373. Okay, look to this point. He said here, the lowest possible temperature for any material is 0 on Kelvin scale. Okay, again, for this point, let us clear all of this, come from here. So the lowest possible temperature for any material, scientists could reach a degree down this one? No. Okay, so the lowest possible temperature for any material is 0 Kelvin. Okay, I can ask you the lowest possible temperature for any material is 0 Celsius. You have to say no, it is 0 Kelvin. 0 Kelvin. Right. What is the name of this one? This one is known as absolute zero. Absolute zero. Okay. So what is the absolute zero? What is the value of absolute zero? Absolute zero equals 0 Kelvin. Absolute zero equals what, شباب? 0 Kelvin. If I said 0 Celsius, so it is a wrong. Okay. Pay attention for this one. So the absolute zero, okay, what is it? It is the lowest possible temperature for any material, and it is 0 Kelvin. Okay. The second point, if a material were at 0 Kelvin, the particles in that material wouldn't be moving and would no longer have kinetic energy. So at absolute zero, what happens to the kinetic energy? There is no kinetic energy. Okay, again, if a material, to this point, if a material were at 0 Kelvin, the particles in that material wouldn't be moving and would no longer have kinetic energy. So at absolute zero, and the absolute zero, it is 0 Kelvin, pay attention. Okay, absolute zero, it is the lowest possible temperature of any material. At this degree, okay, there is no kinetic energy. There is no kinetic energy for the particle type. Scientists have not been able to cool any material to 0 degrees Celsius. Okay, so did scientists succeeded to make a material cool to 0 Kelvin? No, they didn't succeed. Scientists have not been able to cool any material to 0 degree Kelvin. Okay, so I think this paragraph, it's all of it, it's very important. It has a lot of information. Okay, each line is very important. Okay, now come to how to convert between temperature scale. How to convert between temperature scale. We said to convert from Fahrenheit to Celsius. So as you can see here, okay, what is inside the formula is given Fahrenheit. Okay, Celsius here we want to calculate Celsius, so we will give you Fahrenheit. Okay, for example, to convert 176 degree Fahrenheit to Celsius, okay, we said we have an operation here. This operation is subtraction, so do this first. Now we give you 176 degree Fahrenheit, so you have to make 176 minus 32. You do the operation in brackets first. So the answer is 144. Then take 144 and divide it over 1.8. So you will get your result, and don't forget put your number in degree Celsius. Okay. But what if he asked it to convert between the opposite? He gave you Celsius and asked you to convert to Fahrenheit. You will use the second law here to convert Celsius to Fahrenheit. Now you can see that is okay. Celsius is given. Okay. So here in this question, it said convert 86 degree Fahrenheit to Celsius, and here convert 37 Celsius to Fahrenheit. So now he gave us Fahrenheit, so we'll use the first law. Here he gave us Celsius, so we'll use the second law. Okay. We can have, I think we had some problems for this one. Okay, for this one, how can we answer the question? What is the Fahrenheit? So now he wants the Fahrenheit. temperature of the cooler water in this image. What is the cooler water? The water that has low temperature, 25. So we have 25 degrees Celsius. Okay? So we can say the Fahrenheit equals Celsius, and we say times 1.8, and all of this back here is plus or minus. You have to revise your laws. Okay, it is here Celsius times 1.8 plus 32. Plus 32. Sorry here. So Fahrenheit equals Celsius times 1.8 plus 32. So what is the Celsius here given in the question? It is what? 25. How did we know? Because it said the cooler water. So you have to put 25, okay, times 1.8, okay. Then you get the answer, then you add your answer plus 32, and don't forget to put your degree in Fahrenheit. So here, let's see, check the answer, what it was. So we make multiply 25 times 1.8. Okay, so it is 45. So 45 plus 32, the answer is 77. 70 degree Fahrenheit. So your answer is C. Okay, this is how to convert from Celsius, they given in Celsius, to Fahrenheit. Okay, we'll take another example to convert from Fahrenheit to Celsius. This question also, what is the Fahrenheit? Here also, what is the Fahrenheit? Yes, this one, what is the degree in Celsius? Here, what is this degree in Celsius? The freezing point of a solution salt water is found to be 25 degrees Fahrenheit. What is this in degrees Celsius? We said, remember your law, Celsius equals Fahrenheit minus 32 over 1.8. And this between brackets. So you have to do this first. So Fahrenheit is here is 25 minus 32. Okay, we know that 32 is greater than 25. So the result will be in minus, so it will be minus 7. Okay, then minus 7 divide 1.8. Okay, 7 divide 1.8. So the answer will be 3.888 and so on. So if we make rounding, it will be 3.9. So if you have here decimal, don't make rounding, just make round at the last number. Make round at the last number. So the answer here is 3.9. 3.9. I hope these points are clear. So we will do the same for all questions. Let's look here. Okay, now here this one, they give you the temperature here. Okay, in this reading, it is 18 Fahrenheit, and he wants in Celsius. So we will convert from Fahrenheit to Celsius. So Celsius equals F minus 32 over 1.8, the same law. Okay, and if you look here, 660, it means this was 70. So I think this one is 74 Fahrenheit. Okay, this is 5, sorry, 76, sorry, 76, because we have how many dashes? Let's go back. How many dashes? 1, 2. Okay, 74, as we said. So it is what? 74 here, because we have 2 lines on. Okay. Many guys asked me about this one. For this complicated problem, you have to read the question carefully. Okay, according to this table, what is the forecast high for Saturday? Okay, look to for, he asked about Saturday. Okay, and he asked what is the what high. So we have here Saturday. Okay, this high. Okay, and it is in Fahrenheit. Pay attention, it is in Fahrenheit. So I want you to calculate 85 or to convert 85 to Celsius. So Fahrenheit to Celsius, so Celsius equals F minus 32 over 1.8, as we said before. Okay, so just to put 85 here and complete your calculations. Let's see another problem. And also this one is like it. Also here, how many Celsius degrees cooler in the low temperature forecast of Sunday for the than for Friday? Here he wants you to make comparison. Okay, how many Celsius degree cooler is low temperature forecast for Sunday than for Friday? So make comparison between Sunday and Friday. Okay, and he said in Celsius. Here he give you in Fahrenheit. Okay. So you have here 51 and 56. So you have to find what the difference. Then you have to, sorry, and 60, not 56, just Friday. So get the difference. Difference is 9 Fahrenheit. Then you change it into Celsius. So the same law. C equals F minus 32 over 1.8. Okay. And all the next question are the same. Here's also how many Celsius degrees, okay, but here wants what warmer. Here's the degrees in Fahrenheit. Warmer is high temperature forecast for Saturday than for Sunday. Saturday, Sunday, and we want what high, the warmer one, okay? So also the difference is 85 minus 75, it is 10 degree Fahrenheit. So, and we change it into Celsius as he asked in the question. The questions you will have, it's very simple and it will be very direct. Okay, we don't have a lot of information like this one. Okay, it will be a direct question. Okay, now back to our book. Sorry guys, if you have any questions, I just want to finish the lesson just and take your questions. Okay, so here what is heat? We said there is a big difference between heat and temperature and thermal energy. Okay, see here the movement of thermal energy from a warmer object to a colder object. This is called what? Heat. So if you hold a hot cup in your hand, the thermal energy will move from the cup to your hand, right? Like in the picture here. Okay, like here in the picture. Okay, the heat moves from the hot cup to the hand of the girl. Okay, so the thermal energy is moving. So the movement of thermal energy is what? We give it a name, which is heat. Okay, so heat is the movement, and the keywords here is, as I said before, is the movement of what? Of thermal energy. Okay, let's check if we have another point. And also pay attention, thermal energy will move from hotter object to cooler object. Is it the direction? Okay, this is the direction. The same question here, how do heat and thermal energy okay, differ? Heat is the movement of thermal energy from hotter object to cooler object, but thermal energy is what? Is the sum of kinetic and potential energy, the sum of potential and kinetic energy, as we said before. Okay, and we said for this to happen, the movement, we must have a difference in temperature. It means we have hot object and cool object, and heat, thermal energy will move from hotter object to cooler object because they have difference in temperature. Pay attention to the difference in temperature. Okay. But the heat will continue until all objects in contact are in the same temperature. If we have object A and object B and the thermal energy is moving, okay, it is started with 30 and this is what, 20. Okay, The transfer will stop or will end when both are the same temperature. If we divide both of them, this will be 25 and this be with 25. So at this point, we don't have thermal energy transfer. Why? Because now there is no difference in temperature. Okay, this meaning heating continues until all objects in contact are the same temperature. Okay, and this is the end of the lesson. Okay, if you have a question, raise your hand. Who has a question, raise your hand. Ibrahim Ahmed.
Yes, Mister. The PDF it's not opening for me.
Where's this PDF? PDF of what? Of conversion or what?
Yeah, there is
شباب
no PDF like.
لا 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 we have two PDF for this lesson. Number one, to convert between Celsius and Fahrenheit and the opposite. It is on it is on Windigo. The second one, it's like a small quiz. You have two places, Windigo and you have connected microHealth.
Okay, Mister, I don't have it really.
Okay, it is on both websites. What should I do? In both websites, you can find it.
And McGraw-Hill is not opening for me the book.
Okay, for Windigo.
Windigo, I cannot find. I'm not finding the PDF.
No, no, no. It is on the lesson. Ask your friends which lesson, because I can't remember which date.
Okay, Mister. If I don't find it, can you send the PDF to me on WhatsApp?
I don't have on my website. You can download from the website. Okay. Or ask your friends who download, because I don't have on my mobile. Ask your friends to give it to you. Okay. And it is there from 2 weeks. يعني. Ask now. Do you have another question, شباب? Any other questions? Any other questions, شباب? عبد الرحمن سلطان.
Teacher.
Yes.
I didn't understand the Fahrenheit to Celsius.
It will give you the Fahrenheit. Okay, just put in the law. Fahrenheit to Celsius. Okay. This Celsius is Celsius. In Fahrenheit. What is the degree in Celsius? Like this one. Okay, he said here the freezing point of solution of salt water is found 25 Fahrenheit. What is Celsius? You have to know the law. If you don't know the law, you cannot answer. So here's Fahrenheit, because it is given in the question, minus 32 over 1.8. So put it like this one. If you want it to make in one step, okay, no problem. So make it 25 minus 32, okay, over 1.8. You can do it the same, this one, on your calculator. If you want it to make in 2 steps, okay, but you have to put brackets, okay? So brackets will be done first. So when he give you Fahrenheit, so you will calculate Celsius. This is the law of Celsius. Celsius equal Fahrenheit minus 32 over 1.8. Any other questions, Shabab? We still have 1 minute or less than 1 minute. Okay, the two PDFs are on McGraw-Hill and on Windigo. It is there يعني from 2 weeks. Yes, ya Abdul Rahman. Abdul Rahman, you can unmute yourself.
Teacher, I only studied highlighted.
I just highlighted the important points. You have to read to understand, and what I make highlight. Okay, you have to concentrate on this point. Okay, but you have to study all, but concentrate on this point. Okay.
Okay.
Okay, sure. Shabab, this video is recorded. Okay, I'll upload just right now. يعني just after I finish in 1 minute, I'll upload it on YouTube and send the link on Windigo. Okay. So if you want to watch it again, or your friends who didn't attend the session, they can watch the video. Okay يا شباب. Good luck inshallah tomorrow, and don't be afraid. It's very easy questions. Okay, you have 20 questions, 10 multiple choice and 10 true false. Omar, maybe the session